Hello friends, myself R.D. Mahajan presenting my one more video on solution of differential equation by Z transform technique. Solve that differential equation as f of n plus 2 plus 4 times f of n plus 1 plus 3 times f of n, and that is equals to 2 raised to n with the conditions f of 0 is equal to 0 and f of 1 is equals to 1. And to solve this differential equation we apply the technique. In first part, applying Z transform, and in second part, finding its inverse Z transform. Therefore, the given differential equation is f of n plus 2 plus 4 times f of n plus 1 plus 3 times f of n, and that is equals to 2 raised to n. First step is taking Z transform on both the side, and therefore taking individual Z transform, symbolically we can write Z transform was the first term 4 times Z transform of f of n plus 1 plus 3 into Z transform of f of n, and that is equals to Z transform of right hand side. Right hand side is 2 raised to n, and therefore it is Z transform of 2 raised to n. Applying the formulas, Z transform of f of n plus 2 is Z square f bar of z minus Z square f of 0 minus Z f of 1. Standard result. Then Z transform of f of n plus 1, therefore it is 4 times Z f bar of z and minus Z f of 0. All these formulas I have discussed in my first video on that solution of differential equation by Z transform technique. And plus 3 times Z transform of f of n is f bar of z, and that is equals to Z transform of 2 raised to n. Applying the standard result, Z transform of a raised to n is z upon z minus a. A is here 2. Then collecting the terms of f bar of z, 1, 2, 3. In the bracket we have z square plus 4z and plus 3 into f bar of z, and that is equals to z upon z minus 2. Then substitute the values of f of 0 and f of 1 and then transfer that terms to right hand side. Value of f of 0 is 0, value of f of 1 is 1, therefore minus z, it becomes plus z. Once again f of 0 is 0, and then it is equals to multiplying by, we get z plus z into z, that is z square and minus 2z, and divided by z minus 2. Then transferring this to right hand side, we get z square plus 4z and plus 3 as f bar of z, and therefore it is equals to z square as it is, no change, z minus 2z, we get that as minus z. The factors of this, therefore first term z minus 2 as it is, no change. Factors of 3 are 1 and 3, so that the product is 3 and sum is 4, and therefore it is z plus 3 and z plus 1. As f bar of z. We call this as equation number 1. Then multiplying it by z raised to n minus 1 on both sides, we get z raised to n minus 1 into f bar of z is equal to z raised to n minus 1 z square minus z whole divided by z minus 2, then z plus 1 and then z plus 3. We call this equation 2. Then if we see the terms in the denominator, there are 3 terms. Therefore, we have the pole z is equal to plus 2, then z is equal to minus 3, and z is equal to minus 1. These are 3 simple poles. And after getting poles, next step is we require to find out residue at the first pole, residue at the second pole, and residue at the third pole, and then take sum of all that residues to get the required solution or required value of f of n. Obtaining the first residue at z is equals to 2. As per the formula, it is z minus a, z minus 2 multiplied by this term. That term is z raised to n plus 1 minus z raised to n and whole divided by z minus 2, z plus 1 and z plus 3. At z is equals to 2. And then this z minus 2 get cancelled. We get remaining terms as z raised to n plus 1 minus z raised to n whole divided by z plus 1 and z plus 3. At z is equals to 2. And therefore, substituting the value, we get 2 raised to n plus 1 minus 2 raised to n whole divided by 2 plus 1 we get 3 and 2 plus 3 we get 5. And therefore, from this 2 term I can take 2 raised to n common, and therefore 2 raised to n common. Remaining terms are here. It is 2 raised to 1 means 2 and minus 1 and whole divided by 5 3s are 15. And therefore 2 minus 1 we get 1. Therefore the first residue is 1 by 15 into 2 raised to n. Equation number next, 4th. Then the second residue z is equals to minus 1. Applying formula, z minus a minus become plus 1 multiplied by this term z raised to n plus 1 minus z raised to n divided by z minus 2, z plus 1, z plus 3. At z is equals to minus 1. This time this z plus 1 get cancelled, and remaining terms are z raised to n plus 1 minus z raised to n whole divided by z minus 2 and z plus 3. At z is equals to minus 1. Substituting the value at z is equal to minus 1 raised to n plus 1 minus 1 raised to n whole divided by minus 1 minus 2, that term is minus 3, and minus 1 plus 3 we get plus 2. And therefore Once again, from this two term I can take a minus 1 raised to n common. Remaining terms are minus 1 raised to 1 is minus 1 and minus 1 divided by 3 to the 6 minus 6. Minus 2 by minus 6, 2 3 the 6, we get the value as minus 1 raised to n divided by 3 as equation number 5th of second residue. Third residue, residue at the third port z is equals to minus 3. Applying the formula, z minus minus, it becomes z plus 3 into this term. This time this z plus 3 get cancelled, and therefore the remaining terms are z raised to n plus 1 minus z raised to n divided by z minus 2 and z plus 1 at z is equals to minus 3. And then substituting the value, we get minus 3 raised to n plus 1 minus 3 raised to n divided by minus 3 minus 2, that term is minus 5, minus 3 plus 1, we get that term as minus 2. Therefore, from this two term I can take minus 3 raised to n common, and therefore minus 3 raised to n. Split of this one is minus 3 raised to n into minus 3 raised to 1. Minus 3 raised to 1 is minus 3, and remaining terms here minus 1 divided by minus minus, it become plus 5 to the 10. This one is minus 4 by 10 into minus 3 raised to n. Dividing by 2, we get 2 by 5 into minus 3 raised to n, equation number 6. And then taking the sum of all these three residues, equation 4, 5, 6, we get. Adding all the three residues, we have f of n is equals to, the first residue is 2 raised to n divided by 15. Second residue is minus 1 raised to n divided by 3. And the third one is minus 2 by 5 minus 3 raised to n. And sum of all this is nothing but the required solution of that difference equation by Z transform technique. Therefore, this is the required answer. One more I will discuss in my next video. Please like, share it, as well as subscribe to my channel if you are not subscribed yet. And to receive the notification for my new videos, please press the bell icon. Thank you. Thanks for watching.